Okay, good morning, students. So we'll start with numerical problem. Numerical problems. So first one, that's based on the scalar modulator. So you just write down for the following scalar modulator or the following scalar modulator, scalar device, scalar scalar device is characterized is characterized is characterized is characterized by the equation v naught. V output you can consider is equal to v input vi plus 0.1 0.1 vi ka whole square vi ka whole square. Done. So this is your scalar device output. V output is your VO is your output of the scalar device, right? Okay.
Yes.
Then
Yes. Yes.
in continuation with this, the pass band of band pass filter extends from, so its range is from, it extends from 800 hertz to 1200 hertz. Now find all the parameters all the parameters of resulting AM signal. AM signal, that means amplitude modulated signal. You have to find all the parameters. Parameter, okay, so you have to find all the parameters of AM signals. Before going through this problem, you must know what are the parameters of AM signal. You have AC, right? AC, mu, or you can say modulation index MA. These, then you have FM, message signal frequency. Similarly, you have carrier frequency. So these are the parameters which you have to find. And diagram is given. Diagram is given for the scalar model. And what is that? You just draw this. So you have M of t is your message signal. M of t is equal to 2 cos of 200 pi t, right? And then addition of this with your carrier signal that's generated from the oscillator, that's C of t, and C of t here is equal to 20 cos of 2000 pi t. 2000 pi t. From this combination of these two is nothing but your VI, and VI goes to your scalar device. And at the output of scalar device, you will get V output, and that's VO, that's given by this equation, right? And this then goes to band pass filter, and ultimately at the output of this, you will get your signal, that's amplitude modulated signal, SMAT, and you have to find this. And similarly, you can find its parameters once you know the amplitude modulated signal. Done.
Yes, sir.
Okay.
Yes, sir.
So can anybody, before going for this, can anybody tell me what will be the VI, value of VI? That's input to SLD. Can anybody tell me? Because it's just addition of these two signals. Tell me what's VI equal to here? VI is
Send
equal
message
to,
system plus
well done,
carrier signal.
MT. Very well done. Good. Carrier signal, and that is nothing but 2 cos 200 pi t plus 20 cos of 2000 pi t, and this value is equal to VI. Good. Now what's V output equal to? That's given by already by this equation in the question. V output is equal to, that's output of SLD, that's equal to, tell me, VI plus zero point 0.1 VI, zero point 0.1 VI square, right?
Yes, sir.
This is given in the equation. This is given in the question. The equation, the question is itself this. So you're getting, now you know the V input value. Put the value of first in equation second, what you will get. Put the value of equation first in second, what you will get. Just you have done previously. V output will be equal to VI is what? Write on the value 2 cos of 200 pi t plus 20 cos of 2000 pi t, right? And then plus zero point 0.1 2 cos of 200 pi t plus 20 cos of 2000 pi t ka whole square, right? This is your output value of SLD, scalar device, right? Anybody having any confusion till now? Please tell me.
No, sir.
Okay.
No,
No,
sir.
sir.
So just solve then this. So on minimizing or on solving the equation, cos 200 pi t plus 20 cos of 2000 pi t, then zero point 0.1, then a square plus b square. What's the value? A plus b whole square. Then what's this value equal to? A square plus b square plus 2ab, right? Tell me fast.
Yes,
Hello?
sir.
Yes. Please
Yes,
respond. Okay. So first one, a square is 4 cos square 200 pi t. B square is 20 into 20. That's equal to 400, right?
Yes, sir.
Cos square 2000 pi t plus 2ab will be equal to 20, and 2 into 2 is 4, 4 into 2 is 8, 80 plus 80 cos of 200 pi t into cos of 2000 pi t. This is your value, right? This is your value. Now V output finally is equal. V output is this value. You can, on simplifying, you can just write down this. This is your V output. So you can say this is the output of SLD device, that scalar device. Now this SLD is passed through band pass filter. That means this is V output and it will pass through a band pass filter. And band pass filter range is already given here. That its range is from 800 hertz to 1200 hertz, right? Right?
yes,
Yes.
sir.
What does this mean, this range? I will just draw here. So its range can be shown here that you have one, this is 800 and this is 1200 and both are in hertz. Hertz, this is your frequency and this will be obviously its H omega magnitude spectrum of this, yeah, impulse function. This is your value. This may be treated as one or some function value, it depends. Usually we're treating this amplitude as 1. So this is the range of frequencies that will be passed through band pass filter. Now one by one, look at the equation of V naught and just tell me whether this will be passed through a band pass or not, because this is equal to cos 200 pi t. You can just write down this 2 into cos of twice pi fct. On comparing this with cos of 200 pi t, what you will get? This is 2 into 100, 2 pi, 2 pi comparison with this, and this is f. This is your f. This is not f, this t, sorry. T is compared with this. So what you will get? Fc, it's 100. So here Fc is 100 hertz, right? In this case, are you getting or not?
Yes,
Are you
sir.
getting me or not? I'm saying compare this with the general equation of cos twice pi fct. On comparing this and this, what you will get? Fc value or f value for the sake. What you will get? F value, because this is a message signal. This will not be fc, this will be fm rather. So what will be fm value? It will be nothing but your 100 hertz. And 100 hertz will not be allowed by the band pass to pass, right? That 100 hertz will be somewhere here. It will be somewhere here, and it will not be passed by this because its value is 0, and it will be multiplied with your function. Ultimately you will not get any signal in this case, right?
Yes, sir.
Okay, so I will just put a cross mark here to make you understand that this will not be passed by your band pass filter. What about this thing? Will it be passed? Yes, this will be passed because its frequency, its fc, it's 1000 hertz, because its f is equal to 1000 hertz. So it will be passed through band pass filter. So it will be passed, right? Okay,
Yes, sir.
okay. So similarly, this is cos car 200. You can write down this 1 plus cos 2 into 200 pi t divided by whole divided by 2, and you will get 1 plus cos 400 pi t. In this case also f value is your 200, and similarly this will not be passed through a band pass filter. Similarly this will also not be passed because this will be your 2000 hertz frequency. For this it will be similarly simplified like 1 plus cos 2 2000 pi t divided by 2, and frequency here will be 2000, and 2000 will not be allowed by band pass. So this will not also not pass through a band pass. What about this? You just, because these are two product of these cos sine signals, so you say this is equal to, then you will get cos a plus b and cos a minus b. Cos a plus b means you will get 2200 hertz pi t, and plus you will get 2000 minus 200, you will get 1800 pi t, and whole divide will be, in this case this is equal to 2 into 1100, right? 2 into 1100 is what? 2200, and 1100 will be here frequency, and this signal will be passed. What about this? It will be 2 into 2 into 900, and this will be also passed. That means these two signals will be passed through your band pass filter, right?
Yes, sir.
Okay, so final output. So I will say, I will just analyze this V naught once more. So finally, you will, this signal will not be passed through band pass. This will be passed. This will not be passed. This will not be passed, and this will be passed. That means this is the first. This one will be passed, and this one will be passed. Rest all will be attenuated. You will not, these will signal, these functions will not be passed through band pass filter, rather signals will not be passed through band pass filter, right? You can use this term signal and function interchangeably. There's no confusion. Okay, So output I will write here. So band pass filter output, and that is equal to your SAM signal, means your modulated signal. You will get 20, you'll get 20 cos of 2000 pi t plus zero point 0.1 into 80 cos of 200 pi t into cos of 2000 pi t, right? So ultimately you will get this as 20 cos of 2000 pi t plus these two. When you will multiply, you will get 8 cos of 2000 pi t into cos of, this is 200 or 2000, this is 200, sorry, this is 200. First one is 200 and another one is 2000 pi t, and this is your final signal. Now, how can you compare this with your modulated signal expression that you have already done? Can I write this? Can I take 20 common? I will take 20 common. Also, I will take cos 2000 pi t common from both these components. I will get here 1, then here it will be zero point 0.4, because 20 into zero point 0.4 is 8 value, and here you will get cos 200 pi t, and here output this into, you will get 2000 pi t, right? Anybody having confusion in this case, in this particular equation, please tell me. मेरे कहने का ये मतलब है, I am taking cos 2000 pi t common from both the components. Also 20 I am taking common. When you take 20 and cos 2000 pi t common, here you will get 1. That's what I have written. Similarly, you will get, because 20 is common, 20 into zero point 0.4 is 8 value, and बचा क्या यहाँ पे, cos 200 pi t, right?
Yes, sir.
And this is the standard, and this is your standard expression, standard EM expression, rather, expression of single tone signal, single tone AM, amplitude modulated signal. So you can compare this with the general expression, that's AC, as we're already done with this, AC 1 plus mu cos of twice pi FMT into cos of twice pi FCT. Compare equation A and B and tell me the value of AC, mu, FM, FC. Now these values should come from your side, please. Compare equation A and B. Comparing equation A and B. Please tell me the value of AC, mu, FM, and FC. This question ये गेट 2009 में शायद आया था. Tell me the
Sir,
value.
AC is 20.
AC is 20. Very well done.
Maybe 0.4.
AC is 20. Mu is, tell me. AC is 20.
0.4.
Mu is zero point 0.4, right? Okay. 0.4 means what? Mu value is between 0
Yes,
and
sir.
1. That means this is under modulation. Okay, this is not over modulation, this comes under modulation, and that's fine with us because amplitude, this envelope will be preserved. Okay, then FM, anybody?
200 pi t.
No. How can you say 200 pi t? Because this is cos 200 pi t. Can I write this cos of 2 into 100 into pi into t, and then general expression हमारे पास जो होता है, that's 2 pi ft. 2 and 2 is comparison with this pi and pi, T and T, F will be then equal to 100. Are you getting me or not?
Yes, yes.
Yes, sir.
Okay, what about FC? Then tell me FC value. Compare this and this. Tell me FC value. Fast.
So 1,000.
FC is 1000 hertz. Very well done. Very well done. Good. So FC is 1000. And you can see that FM value is very less because this is message signal frequency. And this carrier signal frequency, this 1000 hertz, you can say this is 1 megahertz, right? Can I see? Can you say that? And this is zero point 0.1 kilohertz. That means it's sorry, this is 1 kilohertz, not megahertz. 1 kilohertz. This zero point 0.1 kilohertz. There's a hell of difference between these two, right? Yes or no? Anybody having any confusion? Please tell me. Tell me.